We want to ask questions about how old each of these individuals were when they received this award. Right now we've got their date of birth and their date of award. We're going to need to do some math in order to figure out their age at award. To begin with, on this visualization, I'm going to go ahead and delete the date of death and the notes. I've still got that in the raw data if I need to go back and ask another question about that. But right now I'm really just interested in the age at award. So I've highlighted both those columns. I'm going to come under Edit and delete columns G through H. In column G, I'm going to calculate the date difference. Let me start by giving it that header. So their age is at award is the date of the award minus the date of birth, right? So equals the date of award minus the date at birth, return. I think it has returned the number of days between those two dates. If you got a funny looking date, that might have been that your column was formatted to be dates. If you did get that, let's go ahead and change that column formatting. So we're going to select the whole column G, and under Format, Number, we're just going to make sure that that automatic is checked. Let me see what it might have looked like if it did come out as a date. Right, so if it did come out as a funny looking date, Format, Number, Automatic. I want to calculate that same value, that same formula for all of my records. It looks like I want to copy that formula. I want to fill down. I'm going to use fill. It looks like it's going to work just the same. I'm looking at the bottom right corner. My cursor has changed to a different, to a little cross. That looks like it's calculating that. Let's click and hold and scroll all the way down, taking those little running ants to fill that formula all the way down. Great, we've got the date difference. We know how many days old these people were. It's not really very meaningful though, is it? It would be far more useful to know how old they are in years. Let's calculate that. So in column H, I'm going to give it the heading, age at award, and in brackets, in years. How do I calculate how many years old someone is if they were 8,258 days old? I need to divide that by the number of days in a year. So I'm going to click into H2 where my formula is going to end up. I'm going to type an equals sign. I'm going to click on that person's age in days and say, please divide this by, we need to know how many days are in a year. Do you know how many days are in a year? Don't forget leap years. You got to add a quarter of a day each year because leap years, we get that whole extra day. So we're going to use 365.25. All right, so does that sound right that she was 22, just over 22 and a half years old? Let's see, she was born in 1906. She get the award in 1929. Yeah, that looks perfect. It looks like we're managing our data really well. Let's go ahead and fill that down for all of our records. There they are. Let's get rid of those decimal places. That's not reflecting any degree of accuracy in the calculation. I would think that 2 decimal places is perfectly sufficient. So I have it all highlighted. I could do that again, just click on that letter H to highlight that whole column. And I see hot buttons, very much like Excel's, decreased decimals. There we go. 2 decimal places seems fine. So far Google Drive has acted a lot like Excel. We haven't really noticed any difference. Actually, one thing that at this point Google Docs does better than Excel, and if you are trying to do this in Excel, you will have already noticed that Excel has a bit of a blind spot when it comes to history. Excel doesn't understand that there was time before the year 1900. So these dates where the person was born in the 1800s, Excel is just not programmed to recognize those as dates. So it's nice that Google Docs is, because that made this calculation really easy. If you are trying to do this in Excel, you would have ended up with quite a few of these initial ones being unable to be calculated. This data set is in fact an entire population. This is everybody who has ever won the Academy Award for Best Actor in a Leading Role or Best Actress in a Leading Role. It's the entire population. So how many people are in our population? How many instances are there in this population? So if we look down at the bottom here, we've got, we're on row 177. Remember, there's one row that's a header row, and this is participant row number 176. There's a lot of information there that's telling me that there are 176 people in this population, and it's an entire population. So we have this one variable, age at award, that's measured continuously. It's measured in numbers. It's along a continuum. And we want to describe it. We want to visualize it. To visualize this whole variable for all of these instances, we're going to create a histogram. A histogram will let us visually represent all the members of this data set. It uses rectangular columns to display the frequency of a continuous variable. Along the x-axis, we're going to have the variable, in this case age. We're going to break it into bins or brackets. And then up the y-axis, we will have the frequency, the count, how many people fall into each of those bins or brackets. So first off, we're going to have to divide this data into bins or age brackets. The bins will be consecutive, so they'll come right one after another. There won't be any gaps. The bins will be non-overlapping, so each person will only fall into one bin. Usually we set our bins all to be the same amount of the scale. So if we're going to set bins of 5 years or 10 years, they would all be the same. Once we've decided on our age brackets, on our bin size, we're going to count how many actors and actresses fall into each of those bins, and the column height will indicate that frequency. Google Docs makes histograms fantastically. Excel hates to make histograms. Don't even try to make histograms in Excel. Again, we're going to stay in Google Docs for this tutorial. Let's select our data. We're going to click on the column header H to select all of those ages at award. And under the Insert pull-down menu, we're going to choose Chart. We've opened a chart editor screen. It's recognizing that this is a single continuous variable, and it is suggesting, hey, you want to do a histogram? That's exactly what we want to create. If for some reason your version isn't suggesting this, under the recommendations, we can always go to chart types and scroll down here. Don't be confused. This isn't a column graph or a bar graph. This is a histogram. And I believe it's this one right here. Let's click Insert. And there is our initial histogram of the ages in this population. We can see that between 20 and 25, there are a couple. And then there are a huge number between 25 and 30, even more between 30 and 35. The most between 35 and 40, and then declining down towards the older ages as well. We can see the shape of that population. Before we edit that histogram, let's think about the steps that Google Docs must have taken in order to create that histogram. Let's walk through how we would do that by hand, just in case you ever have to. So to create a frequency distribution, to create that histogram, you're going to need to do 4 steps. So you're going to sort the data from the lowest to the highest. You're going to look at what the lowest value, the minimum value is, look at what the highest value, the maximum value is. That's going to give you the whole range of the data. You're then going to need to divide that scale into equal bins. Those bins must be consecutive, they don't overlap, and they usually would all contain the same amount of the scale. You then go back and you count how many values are in each of your bins. So what this would give you is what we call a frequency distribution, the table, where you've got your bins labeled and then the count of how many observations, how many individuals fall into each bin. Generally, we write the bins like this, where we'd say this first bin goes from 20 to 25, and the second bin goes from 25 to 30. Now, that might sound like someone who's right at 25 would fall into 2 bins, but don't be confused by that. The way we read this when we're reading it as a frequency distribution is we say everything from 20 up to but not including 25. And then we say everything from 25 up to but not including 30. So even though it looks like those might be overlapping, we read them as if they're not. So this is our frequency distribution, the table of the data, the summary of the data in a table format. You then use that to create your histogram. So you set your x-axis to represent the values of that variable. You've only got the one variable, right? And so you set the x-axis to represent the values divided into the bins. You set the y-axis to represent the frequency. And then for each bin, you would draw in a rectangular column, and the height of that column represents the frequency of that value. It represents how many individuals are in that bin. So every member of the sample is represented. They each contribute one slice of each of one of those columns. The bins contain the same amount of the scale, so the columns, the rectangular columns, should all be the same width. If you do lump more values into one bin, then you'd make the bar wider as well. You wouldn't want to distort the data. Let's go ahead and edit this chart, see what our options are. Let's start with the title. I'm thinking that the word histogram of, those 2 words there, aren't adding anything. We can easily see that it's a histogram. So let's go ahead and take those out. We also want to add the sample size, or in this case it's actually the population size, but it would be nice to just add up the number of observations for our audience. So let's see how we should do that. Let's first off start by just taking out histogram of. So age at award in years. I'm going to go ahead and take out that in years because I want to put the population size up here. Because it's a population, I'm going to use the capital letter N. So N equals, do you remember how many there were? I think it was 176, wasn't it? Before we go ahead and edit the other things, let's just think about what we need to edit. So the axis labels, this one is called age at award in years. Yeah, that's great. This y-axis doesn't have a label. It's going to need a label. We're going to need to call it frequency. How about these labels along the scale here? Do you see things do you see information there that isn't useful? I think those decimal places aren't useful. The 0.00s, they're not adding any information. And maybe if we took those out, it would stop doing the zigzag pattern because they would have more room. Should all of the columns be the same color? Yes, they should, because they are all the same type of data. Do we need a legend? Nope, there's only one type of data here. We don't need a legend. That is redundant. How about the bin size? What has Google Docs decided for us? It looks like it goes from 20 to 25, 25 to 30. So it's chosen a 5-year bin. And that, I mean, that looks fine, but we could always look and see what other, how else we might do that. How about the baseline for the y-axis here? It goes all the way down to 0. Because histograms are showing every member of the population, we do need to make sure that they have a 0 baseline. All right, so how do we edit all of those different features? We're going to come up to the top right corner of the chart. There's a little pull down arrow there next to the eye and the pencil. So let's go ahead and click on that pull down menu and choose Advanced Edit. So here we could edit the title again. The next option is about the legend. Let's say none. We don't need a legend. The font, the background. All right. They're giving us options about the buckets. Buckets is Google Docs word for bins. It's saying omit item dividers. What happens if we uncheck that? Do you see what it's done? It's made it look like a whole bunch of little slices all sitting on top of each other. That's reminding us that the height of those columns is directly showing us how many members of the population are in each of those buckets. And so each of those little slices is one individual. I don't think it really adds very much information to see that. It's kind of confusing. So let's go ahead and omit those. But keep in mind that that's what a histogram is doing. It's showing us every member of the population or every member of the sample. Bucket size. So we decided that they're using a 5-year bucket. What if we were to use a 10-year bucket? How would our histogram change? So you can see we've now got those grouped into just groups of 10 years. The same basic shape, but we've really lost a lot of the detail, haven't we? So this is part of the art of data visualization, where you need to choose what's the appropriate level of resolution that shows the pattern, that shows the information, but isn't too much, isn't too confusing. Let's go down to 1-year intervals. Again, we see the same overall pattern. Because they're now 1-year intervals, we've got a lot more variation of the zigzagging up and down because they're only 1-year intervals. It doesn't really add that much more to our understanding. I'm thinking 5 years really is a good way of displaying this information. The decision really is up to you. You want to, all 3 of those are accurately representing this information. You want to make sure that you're representing it concisely and with enough detail that it is telling its story. Following down on our list of formatting, we've got, let's see, the horizontal axis. The title is Age at Award in years. That's great. The number format, that's what we wanted, isn't it? We want to take away the decimals. So let's choose custom. Oh, and even that has done that, where it's taken away the decimals. How are we going to add a title to our vertical axis, to our y-axis? So coming up here where it's in red saying axis, you can see that there's a pull down menu that's saying horizontal and there's left vertical. Our title, we want to be frequency. You could also use count. but frequency is the standard. And when you're happy with your formatting, let's go ahead and say update to save those changes. Now that we have the histogram looking roughly the way we want it to look, let's take a minute and talk about some of the vocabulary and really discuss some of the visual reasoning concepts that we need to apply when we're considering histograms. So I've used a couple of different vocabulary words so far. The first one I used was frequency distribution. Now, the frequency distribution refers to that table of the specific data. We didn't create one of those within Google Docs. Google Docs did that behind the scenes, but we talked about how it would be the table with the bins and the count. The histogram then is the graph of that specific data. That's what we've just been building. Another very related concept is the population distribution. So often you will see a smooth line graph that shows not a specific histogram, but the predicted distribution of the underlying population. Let me give you an example of what I mean by that. Let's say these were your test scores. So on a particular day, this is how the class scored. You can see the yellow bars representing the actual data, the specific histogram of that sample. If I had given the test on a different day or in a slightly different manner, those scores would have fluctuated a little bit. There would have been some variation. The blue line here, where we've smoothed out the particular histogram, is our estimate of the underlying true population. So of all of the possible test sessions, we believe that the population distribution looks like that smooth blue line. There are a number of questions that we ask ourselves when we are reasoning about a histogram, when we're reasoning about a distribution. So remember, you're talking about one continuous variable, the values of each member of a sample on one continuous variable. So the first question you can ask yourself is, where is the center of the data? What value is the data clustered around? You might be near the tallest part of the curve, so you could look at what's the tallest column or the tallest part of the curve, but understanding or trying to identify where the center of the data is. Another question that you ask yourself is, how spread out is the data? What's the minimum value? What's the maximum value? Is the data very tightly clustered in very few bins where the columns will be really tall because there'll be lots of observations in each of a very few columns? Or is it spread out where there'd be lots of small columns with a couple of observations in each of those bins? Another question that you ask yourself is whether the distribution is symmetrical. And we're talking about left-right symmetry here. So does it look like a smooth symmetrical curve, or is there a tail that extends out in one direction or the other? And if there is a tail, are those outliers, is that tail pointing towards the minimum, the negative skew, or pointing towards the maximum, the positive skew? Let's take a look at each of those ideas. When we compare these distributions, and you see what I've done, I've given you population distributions, but you could imagine the histograms underneath each of those curves, right? So if we look at these distributions, we can see that, well, we can see that they're all different. So let me ask you a few questions. Which of these has the lowest center? For which of these is the average or the measure of central tendency the lowest on this scale? What's the difference between the blue distribution and the yellow distribution? Is the difference their center, or is the difference their spread? It's impossible to talk about these distributions without bringing up two concepts in descriptive statistics. So the two concepts that we're going to talk about is where is the center and how spread out is the data. So this is what we've already been talking about, but let me just give you the vocabulary around this. So when we ask where is the center of this data point, we're asking to have a measure or a statistic that describes the central tendency. Often you'll see the mean or the average used for this, not this. But if it is not symmetrical, if the distribution is not symmetrical, then we might use the median, which is the middlemost value. And the last measure of central tendency is the mode, and that's the most frequent value. When we ask questions about how spread out is the data, we're asking about the variability. And the most common measure of variability that you'll be using is the standard deviation. And that goes together with the mean. So whenever you've calculated a mean, you would always calculate a standard deviation. You might also see the interquartile range, that goes with the median. So if you have data that's not symmetrical, you'd be calculating the median and the interquartile range. And a very simple estimate of the variability is just simply the range of the data, how over what amount of the scale does it range. So we've talked about the center of the data and the spread out of the data, and we've also talked a little bit about symmetrical, and I've shown you a few distributions which looked really very symmetrical, and so I wanted to show you one that clearly doesn't look symmetrical. And so you can see here that this is clearly not symmetrical, that the distribution, if it was symmetrical, it would end right about here, and then the mean or the center would be right here with the mode. But what you've got instead is this asymmetry where you've got this tail coming out to the right, and that's going towards the maximum. It's going up the scale. We would call that a positive skew. If this was flipped over and the tail was out here towards the lower numbers, we would call it a negative skew. Oh, look, I've got a picture of those. So here is a asymmetrical with the outliers towards the positive and an asymmetrical with the outliers towards the negative. So when you're asking yourself if the distribution is symmetrical, it either looks left-right symmetrical or it has a positive skew or a negative skew. We need to start writing this up. So we want to copy this into a Word document or into a Google Doc. Google Docs doesn't seem to copy and paste in quite the same way as Excel does. So let me show you how to get this chart out of Google Docs. We're going to single click onto the chart and come up to the top right corner where that little downward facing arrow is. And we're going to choose Save Image. And it's going to save that image as a PNG, which is a portable network graphic. So we're going to click OK to save that image. And that's saved into our download folder, where you can go and find it and add it into a Word document and write an interpretation. So things to think about in your interpretation. You can use your visual reasoning skills and see what is the mode, what is the most common bucket? What's the highest column? What's the youngest? At what age? What are the youngest of the winners? What's the oldest bracket? How old has the oldest person been? Another thing that we use our visual reasoning on a histogram is to think about the shape of the histogram. Does the shape look quite symmetrical? Or are there outliers? So are the outliers towards the younger age or towards the older age? And you can see that there's this group of outliers, that the majority of the data looks very symmetrical, but then there's this extra bump and then these outliers towards the older age. in your interpretation, you'd want to point out the positive skew of this data. To summarize this one continuous variable, we're going to calculate some descriptive statistics. So we've got one variable, measured continuously. We want to know a measure of central tendency, and we want to know a measure of variability. Those two numbers will define the distribution of our data set. So we've got a visual image of the distribution, but we now need to know what's the actual number that what's the actual number that's the central tendency that these numbers cluster around, and how variable is this data set? How much spread is there in the data set? So I've clicked into cell L2 and I'm going to type the word average. I'm going to hit the tab key, and in M2 I'm going to type the word standard deviation, and then in N2 I'm going to type the letter N, capital N. So I'm going to calculate those three numbers: the average, which is a measure of our central tendency, the standard deviation, which is a measure of variability, and then N, just the count. In K3 here, I'm going to type the label all. This is going to be for all of the observations, for all of the records. Here in cell L3, I want to calculate the average of all of the data in column H. Another word for average is mean. So I'm going to insert a function. Oh, look, Google Docs has got some of these very basic functions right there on its formula, on its pull-down menu. So we want to select average, and it's going to ask us average of what? It's asking that of what by having these open parens. So we need to select what we're going to average. We want to average the whole of column H. Let's choose the whole of column H by clicking on the header H. And I'm typing an enter to accept that formula. The average age at which people win the Academy Awards is just over 40 years old. What's the standard deviation? How variable is this data set? I didn't see this on our function easy list. Let's see if we can find it by just typing an equals and then start typing standard deviation. So as I type, Google Docs is popping up some suggestions. And by the time I've typed the ST of standard deviation, Google Docs has suggested, are you trying to type standard deviation? So I'm going to click to select that. It's given me an open paren. I'm going to click the letter H, and I'm going to type the close paren and enter to accept that. And finally, we need a count. So let's see if, oh, yep, just like Excel, it's equals count. $176, that's what we expected. So there's our descriptive statistics for the whole group. The average age at winning the award is 40.64 years of age, with a standard deviation of 11 years. There's quite a lot of variability in that. And this is based on 176 observations. You're going to want to include those descriptive statistics in your write-up. When you do, I would like you to use the letter M as for mean. So you could write M equals 40.64. I want you to use lowercase s full stop d full stop for standard deviation. So you'd say standard deviation equals 11.08. And then for the population, for the count, This is the whole group. We're going to use a capital N. And so those are that's the way that you report that in your narrative. Go ahead and add that to your write-up right now.